Hello everyone and welcome to Mathics. In this video, first I'll talk about strategies. Then I'm going to go from problem 1 to problem 25. And I have done some other questions on Australian mathematics competition. So those questions you'll find more interesting and a little easier. So if you're preparing for this AMC, you could give those questions a try as well. And one more thing, if you are preparing for this course, well, you could also book lessons with me. In our classes together, first we do a set of questions, and then we'll understand what you are good at and the areas you need to work on. Then I'll give you the materials, the topics, and the questions you just need to improve your score. And I'll save you a lot of time. Well, to book lessons, go to About page of my channel. There you will have my contact information and we could arrange classes together. So I hope to see you in class. Okay, now let's talk some strategy. We know that there are 25 questions, okay? And for each question that you get right, you'll get 6 points. So there are a total of 150 points, okay? So if you leave a question unanswered, you will get 1.5. So that means if you take the test and do nothing, you'll get 37.5. Okay, now let's see what your goal is. If you want to go AMY, right? So the AMY's floor these are, by the way, for 2022. For this one, 81, 85.5. So to get there, let's see, if you only get 10 questions right and leave 15 questions unanswered. So you're going to get 10 questions right plus 15 unanswered. Okay. So that will make a total of 82.5. Okay. Okay, that's right. So now you will see that even 10 questions is enough for AMC 12B. Okay. And if you go one more, like 11 questions, 4.5 will be added to this. So if you get 11 right and 14 unanswered, so you'll get 87. So which is way above this. So why am I telling you this? Because you just have to have the right mindset. I see a lot of my students, when they start the test, they're panicked and they just want to go through the easy questions first, and they make mistakes, right? You don't want that. You want to take the maximum time with the easy questions. You want to make sure that you double check everything and you'll have them correct, okay? Because you just have to think about it. Like, I need like maybe 10, 15 questions depending on your strategy. So if you want distinction, 15 or 16 questions is enough, okay? That's what I want you to have in your mind when you are taking the test, okay? Now let's go and deal with the first question, okay? This is the easiest question of all. Let's just start up from here. 3 plus a third, okay? We know that is equal to 3 and a third, okay? So it's equal to 10 thirds, okay? And when we have like this 10 thirds, okay, so we will just create its reciprocal, which is going to be 3 over 10. So this is 3 over 10. So let's just repeat the same process, okay? 3 plus 3 over 10 is going to be this. This is equal to 3 times 10 plus 3 over 10, just in case you've forgotten. I don't think you've forgotten this. So it will be 33 over 10, okay? Again, it's going to be 1 over this. So we're just going to make the reciprocal of that. It will be 3 plus 10 over 33, okay? So the answer is multiplying this 3 by 33 and then add 10 to it. So it's going to be 33 right over here. 3 times 33 plus a 10. Okay. 109 over 33, which is going to result in option D. Okay, question 2. The sum of three numbers is 96. So I'm going to write it like this. We have first number plus the second number plus the third number is equal to 96. Now here, when we read this, we need to find out which one is the smallest number. So the first number is 6 times the third number. So right now between these two, this is the smaller. And the third number, this one, is 40 less than the second number. So we know that the smallest number, okay, is the third one. So I'm going to call this one x. Okay. Then the smallest one is x, so the first one will be 6x. This one said this one is 40 less. So that means the second one is 40 more. Okay. Now let's just add the left-hand sides together. We're going to have 8x's plus 40 is equal to 96. So 8x is equal to 56. So x is 7. Okay, if x is 7, now what does the question want? What is the absolute value of the difference between the first and the second number? Okay, this one is x is 7, 42. This one is 47. Now the difference between them, it could be either -5 or +5. But because here says absolute value, it's going to be +5. 5 rectangles A, B, C, D, E are arranged in a square as shown below. These rectangles have these dimensions respectively. Okay, now is it possible to find the total area? So by that I mean, is it possible to find the area of the square? We know that this is square. Change the color. This is square is made of 5 rectangles, right? And it's possible to find the area of each rectangle and then add them all together. So we'll find the area of the square. So let's find the area of the square. So the area of this will be 6. Let me write it here. This will be 6 plus the area of the next one is 8 plus 30, the big one. 30 could be, I think, this one or this one. I'm not sure. Okay, 14. And lastly, plus a 6. Okay, this is 20, 50, 64. So that means the area of the square is 64. Then what is the each side? Well, of course, each side will be 8. So I'm going to draw this one, 8. So now that we know the side, how to actually go about this question, I think the easier one is just to guess one of them. Like, see, look at this one. This one has the biggest ratio, right? This side, okay, compared to this side, looks the longest. And from all of this, this one has the biggest ratio, 1 to 6. So I would just assume this one is 1 and this one is 6. Then if I'm right, then this one will be 2. Okay, so from here to here would also be 7. Okay. Now with 2, we have 2 times 3, 2 times 7, and 2 times 4. Okay. with 7, we have only 7 times 2, don't we? So that means this one will also be, change the color, this one will also be 2. I'm going with this one, 7 times 2. Okay, then this one will be 6. With 6, we have 6 times 1, 6 times 5. So this one will be 5. So this one here, over here, will be 3. Okay, this is actually 3. So I think everything makes sense. 7, 2, 6, and 5, 3 times 2. So the only one that is missing here is 2 times 4, right? So this one is 2 times 4. Okay, 4 and 2. What is the area of the shaded one? 4 times 2 is 8. And 4 times 2 will be the second one. And here is said respectively. So B would be for the second one. So I'm going to go with B. Let's do problem 4. I think if you do it the right way, this question is one of the easiest questions of all 25 questions. Well, the least common multiple of a positive integer n18 is 180. Okay, so I want you to read this part. Okay, take your time to understand it, and then come up with one value of n, anything that you can. See, for example, n could be 180 is possible for it, and n could also be 90. 90 times 2 will be there, and 90 is not divisible by 18. Okay, 60 is also there. Okay, so you get the idea. So you just go with one of them, right? The easiest for me is to just, is it possible that n is 180? Let's just try. We know that, and the greatest common divisor of n and 45, so I said n is 180 and 45. The greatest divisor of them is supposed to be 15, okay? But we know now the greatest divisor of both of these is 45 because 180 is divisible by 45. This one will be 1, this one will be, okay, 4. But here it says that, okay, it's supposed to be 15, okay? So how to make this the greatest number 15? All we have to do is take away 1 3 from it, okay? So that would be the answer. So because 45 divided by 3 is 15. So let's go. Let's try 60 then. Okay. So if n is 60, okay, what is the least common multiple of both numbers? 16 and 18. Okay, again, it will be 180. And if we have 60 and 45, okay, so the greatest common divisor will be exactly 15. Both of them are divisible by 15. So I think like going with guesswork is also a nice way. I think most of the time it's just a faster way to deal with these type of questions. I'll see you in the next question. Okay, problem 5. The taxi cab distance between points x1, y1 and x2, y2 in the coordinate plane is given by this. For how many points P with integer coordinates is the taxi cab distance between P and the origin less than or equal to 20? Okay, so this is the first type of question that when you see, you have no idea if it's going to be difficult or it's going to be easy. And I see a lot of students will just panic, says, wow, this is getting difficult, I can't do it. Well, don't panic. All you have to do is come up with some points and then let's see if you can find a pattern. Okay, let's do that. First of all, we just want the comparison between the x values of 2 points and the y values of 2 points. So for example, if we have 2 points, You'll find the x's and then you subtract, okay? And then you find the y values and then you minus them, okay? But fortunately, one of them is the origin, okay? That means the coordinate of this one is 0 and this one is also 0, okay? So all we really have to do is come up with some points over here, okay? Now, x1 or y1, okay, could be 20 or less than 20. Let's go. If x is 0, like this, the greatest value of y1 could be 20. Also, it could be x1, 0, 19, 18, 17, all the way to 1. Okay, because here we have the absolute values, these 20 values will also be included. Okay, x being 0, y could be ranged from here. So the other case would be, okay, now y is 0, and this one will go all the way to 20. And or this one all the way to 20. So how many points did we find already? 81, not 80, 20, 20, 20, 20. And the point 0 and 0 over here is again one of them. Let me highlight it by red. Okay, now let's see. If, okay, x1 is 1, the maximum value for y will not be 20, but will be 90. So we're going to get 19 points here instead of 20, 19. If x is 2, then from here we're going to get 2 and 1, 2 and 2, 2 and 3, 2 and 4, blah, 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 18. Okay, and the last one over here, we'll get to here. You see, it's going to be 17, 16, 15, all the way to here. So when we just have to add this, okay, so from 20 plus 19 plus 18, but it will be 1/4 of it. The same thing will happen here, the same thing will happen here, the same thing will happen here. And remember, so now we're going to go with this part. Okay, I'm done. Okay, this one, this axis over here will be for the next one, by the way. So this axis will be for this one. My picture is not that accurate. Okay, so the orange one will be 20 plus 19. Okay, all the way to plus 1. Okay, and then this will happen 4 times. What is the sum of this? Well, the first number and the last number, 21. The second number from here, the second number from here, 19 and 2 plus 21. How many pairs like this do we have? We have 10 of these. So the sum will be 10 21s. Okay, so it will be 10 times 21. And remember, we had 4 of this. Okay, orange, red, blah, blah. So it's going to be 4 of this. And there was 1 point, right, in the middle. It's going to be plus 1. Okay, so it will be 210. So 840 plus 1, 841. Okay, so just you have to go through the same steps. Come up with some points. Let's see if you can come up with a pattern and a system to count all of them. Okay, problem 6. You have to be careful about problem 6. It appears easy, but you have to be careful. There's a trap set in the question. A data set consists of 6 not distinct positive integers. The average of the 6 numbers equals a value in the data set. Okay. Now, when we find the average of these, it will be one of them. Okay. So just let's write the formula for arithmetic mean or average. So we just need to add all of them. 1 plus 7 plus 5 plus 2 plus 5 is 20. So 20 plus the last one, x, divided by 6 number. is going to be one of them again. Is it possible for this one to be 1? Yes, but x will be negative 14. But here it says positive integer, so not possible. 2 will make x negative 8, not possible. We don't have 3. The next number here, we have 5. Then here, from here, x will be 10. So the first number, we have it. Okay, now it could also be 7. So 6 times 7 is 42 minus 20, 22. So we just have to find the sum of them. Okay, so when you add them, 32, and it's already one of the choices. But you have to ask yourself at this point, isn't that too easy for problem 6? I think the answer is yes, because we have to be careful, right? Now the question has been designed nicely. When you put x over here, we're going to have 20 plus x is equal to 6x. So when we solve it, we're going to have x is equal to 4. So this one is 4, will result to this 4. So if 4 is one of the numbers here, when you find the average, okay, so everything works. So x is equal to 4 is again another one over here. Okay, so 32, the trap, plus 4 is 36, the right answer to the question. Okay, let's do problem 7. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color, red, orange, yellow, blue, or green, so that regions that touch are painted different colors, and colors can be used more than once. How many different colorings are possible? Okay, so it doesn't matter. Pick any of these 5 rectangles. Okay, I'm gonna go start from this edge over here. So I have 5 possibilities, right? For the 5 different colors to paint this one. This one is a neighbor to this, okay? So I'll have 4 options. If I use here red, I can't use red for here, so it'll be 4. This one is neighbor with these 2, so I've already used up 2 different colors, 3. But when we get to this one, it wouldn't be 2, right? Why not? Because from the 5 colors that are available, I can't only use the one here and the one here, okay? So this one is also possible. So from 5, these 2 are not possible. So here would be 3. Now with the same reasoning, okay, I could use 5 colors except the one that I used here and except the one that I used here. So again, it will be 3. So all we have to do is multiply these numbers. It's going to be 27, 3 times 3 times 3, multiplied by 20. Okay, 548. Okay, question 8. This infinite product values to a real number. What is that number? Okay, for all these infinite products, divisions, or continued fraction that you see, the trick is always the same thing. Okay, you would call them, like, let's assume this is t. Now here, maybe a part of this is t. You have to find it. Okay, now we will create t again if we cube both sides, because we'll get rid of this one. Let's see. So we know that when we cube this, okay, all of this infinite will be cubed. And this cube is for each one. So it's going to be like this one cubed, and this one cubed. So we're going to have t cubed is equal to this one, this 3, and this 3 will cancel. So we're going to get 10. And this 3 and this 3 will cancel again. So we're going to get, okay, the third root of 10. Okay, multiply by the third root of 10. And look, we made t again, right? Let me clear this. You will see here that this is again t. this is again t. Okay, so we just have to find a value, okay, that applies here. So we're going to go, it's not working. So we're going to get t cubed is equal to 10t. Obviously, t0 is one of the solutions to the equation, which is not an answer to this. Well, because of course it's going to be a number except 0. Okay, so let's divide both sides by 1t. We're going to get t squared is equal to 10. So t will be positive or negative, a square root of 10. The negative 1 will not be possible because all these terms are positive. So the answer would be a square root of 10 right over here. On Halloween, 31 children walk into the principal's office asking for candy. They can be classified into 3 types. Some always lie. We're going to show them by L. Some always tell the truth, okay? And some alternately lie and tell the truth. The alternators arbitrarily choose their first response, either a lie or the truth, but each subsequent statement will just have the opposite value. Okay, the principal asked everyone the same 3 questions in this order. Are you a truth teller? Okay. Now, we're going to have actually 2 different set of groups. So we're going to have 2 groups of people who alternate, okay? Some of them will start by lying. Some of them start by telling the truth. And the total number will be 31. Okay. Now, the principal would ask, are you a truth teller? Who would say yes to this question? Truth tellers obviously would say yes. Okay. The liars would say yes, I'm a truth teller. And we also have another group of liars who say yes, I'm a truth teller. Okay. So these 3 people are actually 22. So we have the number of people here. Okay. That would say, start by saying the truth, which would be 9. So this one is useless. We already know it. The first response would give away this one, okay, unnecessarily. Okay. But by the way, okay, let's continue. The next one would say, are you an alternator? The principal gave a piece of candy to each of the 15 children who answered yes. Okay. Who would say yes to this question? Truth teller? No. Liars would say that. Okay. So we're going to have liars plus some people who lie would say, I'm an alternator. Okay. So, but which ones? The ones who would say the truth will say yes. The one who are lying wouldn't say this. But this time, AL will say the truth because previously they lied. So A plus AL will be 15. Now look at here. So we already had L plus T plus AL was 22. Now L and AL is 15. So we're going to have, so let me write it again so that nobody will be confused. We had this from the previous one. Now compare these 2. L and AL together will be 15. So we're going to have T plus 15 is equal to 22. So the value of truth tellers will be 7. But the question is not asking for the number of truth tellers. It says how many pieces of candy in all did the principal give to the children who always tell the truth. So the truth tellers. So for the first question, are you a truth teller? They said yes. So they get 1 piece of candy here. Are you an alternator? The truth teller wouldn't say. Are you a liar? So they actually get candy only once. So The right answer would be right over here. Okay, not very difficult, was it? Okay, question 10 is one of those questions when you read it, you have no idea if it's going to turn out to be difficult or easy. So, but don't panic. Let's just come up with some examples and you see it's not really that difficult. How many ways are there to split the integers 1 through 14 into 7 pairs such that in each pair, the greater number is at least 2 times the lesser number? Okay. So I'm going to go and write down all the numbers 1 to 14. Okay. And I'm going to ask you to think about the ways we could put them into pairs. My question to you is now, can I pair, for example, 1 and 3? Is it possible? The answer is no, you can't pair 1 and 3. Why not? You see now, these 7 bigger numbers from 8 to 14 are one group, okay? And these are another group, okay? So each member of this group has to be with this group, okay? If you put 2 of these together, so for example, you say, okay, let's just put 2 and 5 together. It's possible, right? Because 5 is more than 2 times of 2. So you're allowed to put them together. So you would go and put 2 and 5 together. Okay, but if you do that, okay, you will not have enough numbers for these bigger numbers. Let's try. So you would go 14 and 7. Okay, let's go. And then you will go 13 and 6. Okay, 12 and 5 is gone. So you have to go with 12 and 4. Okay, 11 and 3. Still good. And then we're going to go with 10 and 2 is gone. So we have to go with 10 and 1. So now what numbers are left? Okay. So, and we haven't used 6, 7. We have used 5, 4, 3. Okay. Now the problem is a lot of numbers are left. 8 and 9 are left from here. And what else is left here? Okay, I'm sorry. So we have 6 groups. I didn't count this one. Okay, we have 6 groups. So 12 numbers have been used up. Now you'll end up with 8 and 9, which cannot be put in one group together. So what can we say here? We can say that each number from the left group has to be put together with each number from this group. Okay, that's the first thing. Now let's go over here. For 8, the smaller number, which numbers are possible to be put into the group? 1 to 4. So 8 is lucky. We'll have 4 possibilities for this one, multiplied by. For 9, okay, we can't use 5, 6, 7. These 4 are available, but 8 has taken one of them, so there are only 3 available for 9. For 10, these 5 numbers are available. 2 of them have been taken, so 3 are left. For 11, okay, again, these 5s are available. 3 have been taken, so 2 will be left. So for 12, 6 will be added. So 6 numbers are possible. 4 of them have been taken, so 2 will be left for 12. Okay, so that's going to be like 5. Okay, so for 13, only one number will be available. And for 14, only one number will be available. So all you have to do is multiply these numbers. So it's going to be 9 times 4, 36 times 272 times 2, 144. So the answer will be E. Okay, problem 11. What is the product of all real numbers x such that the distance on the number line between these two logs is twice the distance on the number line between log 10 base of 6 and 1? Okay, Now here, the first question is, why does it say products of all real numbers x? Because if you put x here, so we're going to have only one number for this. So there must be only one solution. But why does it say product of all real numbers? Okay, to understand this better, let's call this one A and call this one B. And they could be randomly anywhere, okay, on the number line. Maybe it's going to be like this. A, B. And from here to here, we're going to call it distance. It's going to be D. Now here it says the distance between these two must be 2D, twice of that. Okay, this one is already a number. We're going to call this C. So from this C, the distance should be this one, and the other number should be 2D. But here we have two possibilities. Maybe, okay, this way, 2D this way. Okay, or maybe 2D backwards. Okay, so we're going to have two solutions. Okay, so first, let's just follow the same steps. Let's find the distance D. Okay, D was the distance between these two. So I'm going to write them like this. D will be log of 10, okay, with base of 6. Minus 1, instead of 1, I'm going to write log of 6, okay, this way. This is D. So we know this is being subtracted, so we can write it as a fraction. The base will be the same, okay. Then it will be this 10 divided by this 6. So it's going to be 10 over 6. We could also simplify this. This is normal fraction. So I'm going to write it as, oops, I'm going to clean it, 5 over 3. Okay. But we want 2D, so 2D will be like this, okay? And we know that this number could be the power of this number, okay? So 2D, well, actually, I'm going to write it here. 2D will be, okay, a log of 6. 5 over 3 multiplied by 5 over 3 is going to be 25 over 9. Okay, so we're going to have this 2D. So we're no longer going to need this. We're no longer going to need this. So from this point C, once we're going to go this much forward, once we're going to go backward. Okay, so now to find x, this log of x, okay, over 6. It's going to be C. C will be this much. So I'm going to write it here. Log of 9 with the base of C. Once we're going to go 2D forward. So it's going to be plus log of 25 over 9. Okay. So now, as you would see here, okay, the left-hand side will be, okay, like this. Now, because here there's plus between them, we're going to multiply these two numbers. So it's going to be log of 6, okay, 9 multiplied by 25 over 9 will be 25. And by comparison, you see the first x will be 25, okay. Now let's go and find the one that was backward, okay? From point C, which was this number, C, we're going to go 2D back. Let's go and do that. So all we have to do is minus these two values, okay? We're going to go 2D backward. Because here now we have minus, we're going to subtract the left-hand side. Will be untouched. So this one, I'm going to write it here. The base will be 6. Now 9 divided by 25 over 9. What's that? is going to be reciprocal of that, then multiply. It's going to be 85 over 25. So by comparison, you would see this is the value of x again. So the second value of x will be 81 over 25. And once we multiply these two, obviously it will be 81. So I'm going to choose E for the answer. Okay, let's do question 12. Let M be the midpoint of AB in regular tetrahedron ABCD. What is the cosine of this angle over here? CMD. Okay, we want this angle right over here. Okay, just please note that these black ones, for example, CA is the side, and this one is a median. Okay, so let's go. I just want to draw this one, this triangle over here. Okay, so I'm just going to keep the red ones like this, and the red one like this, and this black one will be just looking this way. So CD will be right over here. And now I'm going to ask you, which one is larger? The red ones are larger or the black one? Okay, the black one is the side, the red one is a median. Okay, so actually these are smaller. Okay, because they are smaller, so this angle is going to be more than 60. Okay, if everything was red, all of them side would be 60. But since these are shorter, so it becomes like this, so the angle will actually increase. So it means we know that cosine of 60 degrees is 1 over 2. And when the angle increases, it gets smaller. So this can't be the answer. This can't be the answer. So we know the answer is one of these three. Okay, and now how to actually solve it? It's not going to be really difficult. So, oops, all we have to do, let me just do some cleaning here. Okay, so in this triangle, okay, over here, look, so pay attention that this is perpendicular now, okay, in ACM triangle. Okay, now it's a ratio question. So we could call this one, for example, A, but it's a bad idea. Okay, let's just call it 1. It would be easier. So if this one is 1, so that means AB is 2. That means each side is 2. So this is also 2. Okay. Okay, this one is 1, this one is 2. So how large is this? This one, the red one, is going to be 2 squared minus 1 squared will be this red one is squared. So it will be radical 3. So this one is radical 3. So now the question turns into this. This is square root of 3, square root of 3, and this one is 2. Okay, this is what you're going to do. So I'm going to clean everything else, okay, because we no longer need them. So how do you deal with this? Okay, so I think the easiest way is using the cosine formula, the law of cosine. Okay, so in case you've forgotten it, I'm going to write it again. So if this one, let's call this one C, this one is A, and this one is B. Okay, I know that they are the same, but I'm going to write the general formula. So it's going to be like this: C squared is equal to A squared plus B squared minus 2AB cosine of this angle. Let's call it theta. This is theta now. Okay, so let's just replace numbers. It's going to be C squared will be 4, A squared will be 3 plus 3 minus 2 times the square root of 3 multiplied by the square root of 3 will be 3 again, cosine of the angle. Okay, so it's going to be, okay, let's just have it here. It's going to be negative 2 is equal to negative 2 times 3 cosine theta. The negative 2's will cancel. 1 and 1. So cosine theta will be 1 over 3. Okay, not a difficult question, was it? No, not real difficult. Okay, so it's going to be this one. Okay, problem 13. Problem 13 is an easy question with a lot of big words. It's very scary, but when you do it, it's actually super easy. Okay, now let's see. Let R be the region in the complex plane consist of all complex numbers z that can be written as the sum of complex numbers z1 and z2, where z1 lies on the segment with endpoints 3 and 4i. Okay, so let's see what actually this question is saying. Let me make this a little larger. So we're just going to have a complex plane, okay? So this is like a, okay, the number line that we know. So we're going to call this one R, okay? And we're going to add the imaginary axis to it right here, okay? And now it's saying that Z1 lies on the segment. Okay, so there is a segment with endpoints of 3. This is going to be real. 1, 2, 3. It's going to be like this point. That's one of the endpoints. And 4i. 1, 2, 3, 4. Okay, this is going to be the other one. So now the segment, let me turn it to a line. Okay, segment is this. Okay, and Z1 could be any points on this line. So Z1 could travel, be at any place here. Okay, so what is Z2? Z2 has the magnitude at most 1. Okay, when we give magnitude, we have to think about it as a vector. Okay, so Z2 will go away just like 1 unit away from Z1. Okay, so it could be all real if this one is Z2. If it's traveling like this, it will be all real. If it just goes up, it's going to be all imaginary. Okay, but it could also go anywhere here. Magnitude is 1. It could travel like this. Now, what integer is closest to the area of R? Okay, so we just have to go from each Z1. Okay, this could travel. So from, for example, this point could be like this one. See, from each point, we're going to be like 1 away this way, 1 away this way, 1 away this way. If we do it like this, so it turns into a rectangle. So it's going to be like this. But also, we know that it could from here goes like 180 degrees also this way. So it will turn into a half a circle. Okay, and from here into half of another circle. Okay, so now here it says 3 and 4. We already know that this segment is 5, which is going to be one side of the length of the rectangle. This one was 1, so this is 2. Now the area of the rectangle is 5 times 2. Okay, now let's go plus the area of the circles. The radius is 1. This half and this half will make a full circle. So it's going to be pi. 1 squared is 1. Okay, so it's just that integer is closest to this. It's going to be 13.14. And it's going to be closest to 13, which is the right answer. It's going to be option A, but I have to put it here. So that would be the right answer to the question. Okay, problem 14. What is the value of this expression? And we know the base of the log is 10. So before we start, I just have to highlight something. We know that log of A, 1 is the power of B. We could write it as B log A. Okay, but we cannot do this here because now there is a bracket over here, and then so we do the log, the function of log, and then we cube it. So it's different. Now that means you cannot use this rule over here. So we need to think of something else. Let me clear. Okay. Okay, now let's see. We know that the log of 10 when the base is also 10 is equal to 1. Okay, if you pay attention, every term is made of maybe log of 2 or a combination of log of 10 and log of 2. So for example, the first one will be the log of 10 over 2. Okay, cubed. The second one is the log of 10 times 2. The third one is only made of, okay, log of 2 cubed. Okay. And the last one is going to be log of 1 over 4. And 4 is actually 2 squared again. So I could rewrite everything here. We know that log 10 is 1. So this one will be 1 minus the log of 2 cubed plus 1 plus the log of 2, again cubed. So this one, the power will jump down. It's going to be 3 times log of 2, okay, multiplied by, okay, this is going to be negative 4, multiplied by negative log 2, okay. So remember, for this one, why is it negative log 2? We could write it as log of, okay, 4 to power of negative 1. This negative 1 will come here. That's why it's negative, but I forgot something here. And 4 is going to be 2 squared, so it's going to be negative log of 4. This one will again be 2 squared. So it's going to be like this. And this 2 will again jump. So it's going to be like negative 2 times of this. Okay, I'm going to add this too. I forgot to write it. Okay. So now for simplicity, we could just, instead of the log of 2, we could just put a variable. So it's going to be 1 minus t, okay, cubed, plus 1 plus t cubed. Okay. So 3, this will be t minus multiplied by negative 2t. Okay. Now all we have to do is expand this expression. I'm going to have some space. Okay, now let's expand it from here very quickly. So the first one is going to be 1 cubed plus, minus t cubed. Okay, it's going to be minus 3 t squared. Also, it's going to be plus, okay, 3. This is going to be plus. This will be minus 3t. Okay, that's the first one. And then the last one is, the next one will be 1 plus t cubed, okay, plus 3t, okay, plus 3t squared. And these two together is going to be negative 6t squared. Now we're just gonna, okay, so these are negative t cubed. We'll go with positive 1. Sorry, with this one. This one will cancel. No, this negative 3 will go with this negative 3. And look, this positive, this one, and this one will also cancel. So what will be left is just this one and this one. It's going to be 1 plus 1, which is going to be 2. So the right answer here will be 2, which is going to be the option C right over here. The roots of this polynomial expression are the height, length, and width of a rectangular box. Okay, So we know that this equation, this expression, has 3 solutions, okay? So I'm going to write it like this. The first solution, let's assume it's A, okay? The second solution, let's assume it's B. And the last one, let's assume it's C, okay? Now, these two expressions, are they equal? No, because when we multiply x by x, okay, we're going to have x cubed. But you see here, this one has 10, okay? For both of these to be equal, I'm going to add this 10, okay? Now, for any value of x, this side is equal to this side, okay? Now, we could go on and expand both of these, actually this one, and compare. So maybe we could find A, B, and C, find 3 solutions. But do we really have to do this? Let's see what question wants. A new rectangular box is formed by lengthening each edge of the original box by 2. What is the volume of the new box? So, okay, once we have A, B, and C, okay, so we're not just going to multiply these two. We're going to find A plus 2, okay, because each side will be lengthened by 2. And lastly, it will be C plus 2. Okay, now one way is to go and find 3 solutions here, okay? Or the other one could be expand this, okay? This is like the standard solution, and then compare. Or what you could do is just outsmart the question. How? Okay, now we want this, right? So now if I go and put 2 here, okay, instead of all x that you see, I'm going to put plus positive 2, okay? Then what happens to the right-hand side? Okay, it will be 2 minus a, okay, multiplied by, okay, this side will be 2 minus b. This one will be 2 minus c. But actually, this is not what we want. We want to add to it, right? So we want a plus 2, but we are creating a minus 2. Okay, even if we multiply everything by like negative 1, okay, we could still get, if I multiply this one by negative and put a negative outside, we could create a minus 2, right? Multiply each one by negative 1. Okay, we could do that. It would be, so it's possible to find the volume of this one when it shrinks by 2, if I put x plus 2. But we could just do something else. Instead of putting x positive 2, so I'm going to go and put x equal negative 2 everywhere. Okay, now if we plug in the value of x equal negative 2, what happens? Okay, let's try this one. Okay, so what we're going to get is this one will be negative 2 minus a. This one will be negative 2 minus b. And this one will be negative 2 minus c. Okay, but are they equal, right? So is this the same as this? No, not really. Okay, but one thing, in order to understand this better, if I have 2 plus 3, if I ask you this, well, what is 2 plus 3? Obviously 5. But look, I could write the same thing as negative 2 minus negative 3, okay, multiplied by negative 1. This is still 5, right? You just have to multiply this. Let's try it. Negative 1 times negative 2 is 2. Negative 1 times negative 3 is going to be positive. It's still 5. Okay, so they are equal. What does that mean? It means that we could change all the signs of here, okay? Positive, positive. We turn both of these into negatives, okay? at the cost of adding a -1 like this. So we're going to do the same thing here. Okay, let's do that. So each one, okay, I'll make both of these positive, but I multiply by -1. I make these two positive, I multiply by another -1. I make both of these positive, okay, again I add another -1. So we know that -1 times -1 times -1, of course, is just -1. So I'm just gonna go, instead of all of these, okay, these three, I'm gonna put just one negative. And here we have a 10. So let me write the 10 and add the negative here. That's gonna be the right-hand side. So now you would see that we created this V. So this is actually V, right? So I'm gonna like clear all of this. Okay, and remember, this time instead of X, we're just gonna plug in the value of -2. So we're gonna have 10 -2 cubed minus 39 -2 squared plus 29 times -2 minus 6. So all of this will be -300. So we're going to have -300 is equal to -10 multiplied by V. So actually the value of volume will be 30. It's going to be D. Okay, this is the smartest way to answer this question, right? Because it's a test. We need to come up with the ways that we could answer these questions as quickly as possible. Okay, problem 16. A triangular number is a positive integer that can be expressed in the form of blah, blah, blah for some positive integer n. The three smallest triangular numbers that are also perfect square are 1, and T8 will be 36, which is equal to 6 squared. That's why it's a square number. And T49, okay, which is equal to 35 squared, which is the next one. What is the sum of the digits of the fourth smallest triangular number that is also a perfect square? Okay, so we need to analyze the ones that we have better so that we come up with a pattern. So first of all, we have T8 over here. What does that mean? It's going to be 1 plus 2 plus 3 plus 4 all the way plus 7 and plus 8. So I hope you know the formula. The value of this will be, okay, is equal to 8 times 8 plus 1 is 9, okay, divided by 2. And now what happens? This is the crucial part. You see, 9 is already a square number. And when we simplify these two, 4 will also be a square number. So 4 times 9, we can write this as 2 squared multiplied by 3 squared, which is why it is 6 squared. Okay. So now let's try the other one. So now let's go for T49. What does that mean? 1 plus 2 plus all the way to 50. So the value of this will be, okay, 49 is already a perfect square. We multiplied by 50, the even number. But when we divide, when we cancel 50 and 2, we're going to have 49 multiplied by 50, which is equal to 7 squared, multiplied by 25, which is equal to 7 squared multiplied by 5 squared, okay, which is equal to 7 times 5 squared, which is going to be 35 squared. So hopefully you know what to do now. You see, now When in our search, we should look for the numbers that are already an odd perfect square. And then maybe one after them 50 or one before them 48. When we divide them by 2, they have to also be a perfect square. If they're not, we move on to the next number. So for example, now this is 7 squared. The next number that we need to check is 9 squared. 9 squared is 81. Okay, so one number back is going to be 80 or 82. When we divide both of these by 2, the first one will be 40, 41. They're not perfect square. So 9 squared is out. We have to go with 11 squared. 11 squared is 121. So 120 and 122 divided by 2 are not perfect square. So we have to move on. We have to do this until we find a number. The next one, 13 squared, is 169, 168, and 170 divided by 2. Not going to be perfect square. So the next one, 14 squared, will be, we don't want to search, it's just odd numbers. So 15 squared is going to be 225. One more, one less, 224, and 226. When we divide them by 2, 113, 112, not perfect square. Move on. So the next one is 17 squared, 200. This one is good. This one is the answer. So 17 squared is going to be 289. Okay, one less than that will be 288. When we divide it by 2 is 144, which happens to be a square number, 12 squared. So we got our answer. So, but what t is this? Okay. I have to write it as t 288. Why? When you want to find this, what is the answer to this? Okay, it will be 288 multiplied by 289 divided by 2. Okay, that's very good. So when we divide this one and this one, it's going to be 144 multiplied by 289. Okay, so both of these are perfect squares. So this is going to be like 12 times 17 squared. This is the number that we're looking for. So, okay, so let's go and find the number. So 17 times 12, 170, 34 is going to be 204 squared. Okay. So 204 squared is going to be equal to, let's just multiply it the normal way. So let's just find it. Okay, it will be 816 plus 2 zeros, 804. Let's add them all up, 61614. Okay, now we want, what is the sum of the digits of the fourth smaller triangular number that is also perfect square, which is this number. So it will be 7, 14 plus 4. We add all the digits, it's going to be 18. D again. Okay, suppose A is a real number such that the equation, as you see, this is the expression, has more than one solution in the interval. And because it's supposed to have one solution, then the set of all such A that can be written in this form is going to be like this, where PQR are real numbers with P being smaller than Q and Q also smaller than R. What is P plus Q plus R? So first of all, I think this problem is very, very long to solve. And the chances of you just starting it and then dropping it in the middle of the way is very high. So if you see this question in a test, maybe it's a good idea to skip it altogether. Okay, the solution provided on the website is very straightforward, but very long. And so I'm just going to explain the parts that may be a little hard to understand. So here, for example, for this one, this is the question. Instead of sine 2x, we're going to have this. Okay, so why? Because instead of a and b, we're going to put x and x. Okay, so what we're going to get is sine x cosine x. So it's going to be like this. Sine 2x, okay, will be the same as sine x plus x. This is what we're doing. Okay, so what we're going to get here will be sine x multiplied by cosine x. And again, we're going to have the same thing. Plus, again, sine x multiplied by cosine x. Okay. So we're going to have 2 sine x cosine x. Okay, so this is what we're going to have, okay, for this one. Okay, so this was kind of the obvious one, but let's just see something else here before we do it. So what is cosine? Because we're going to need this later. Let's just do it now. Cosine x plus x, which would be cosine 2x. Okay, it will be equal to cosine 2x, okay, plus, no, I wrote it here even wrong. So let me get it here. So it'll be like, there's a minus here, and this one will also be minus. So it's going to be like cosine squared minus sine squared. Okay, so we're going to need this one as well. Okay, so lastly, let's go and expand this one, sine 3x. Okay, so to do that, let me write it here. It's going to be like sine 3x. Okay, so this one we're going to write it as sine, okay, 2x plus x. Okay, and then we're going to use this formula over here. So we're going to have, it's going to be, instead of sine a, we're going to have sine 2x multiplied by cosine x plus, okay, cosine 2x multiplied by sine x. Okay, so instead of sine 2x, we're going to write this value that we had over here. And instead of cosine 2x, we're going to have this value over here. Okay, let's go and do that. So we're going to have 2 sine x multiplied by cosine x, and there's an additional one here. So I'm going to write it as cosine 2 cosine squared x plus, instead of cosine squared, we're going to write it as cosine squared minus sine squared. So you would see if you don't know this formula, and my pen here is a little slow that I'm writing it here, so it's taking extra time. So now we just have to, okay, factorize this. So we're going to get sine x, we factorize it. We're going to have like 2 cosine x plus another one here over here. So it's going to be plus another cosine squared x. Now minus sine squared x. Okay, so we're going to get rid of this sign here. Okay, so the basic trigonometry formula. Okay, so we're going to have, I'll write it here, sine x squared plus cosine squared. Right? We know that this is 1, right? So instead of sine squared, we're going to have 1 minus cosine squared. Okay, this would be, instead of sine squared. So instead of sine squared, I'm going to replace this value. So this is now the value we're going to get. We're going to get sine x. Okay, so it will be, okay, 3 cosine squared. And instead of this, we're going to get minus 1 plus another cosine squared x. Okay, so now I'm going to show you here the value. So now this is the part that, like the solution just wrote it immediately at the beginning of the explanation. Let's just see it here. Let me clean everything. So this value that we got over here, okay, is equal to this part. So this one that we got here is this part over here. Okay, so in case you didn't understand why this is from, I just included this part. Okay, now let's see the rest of the solution here. So as you see, everything, we got rid of 2x and 3x. Okay, this was what we did here so far. And now you see that all terms, this one, and this one has sine x. So we could simplify it, like each term we divide it by a sine x, and a sine x, and a sine x. But we have to be careful, okay? Because if sine x, the value of this is 0, you can't divide something by 0. But here the question said that the value of x is between 0 and pi. So 0 and pi are not in the domain. So easily we could simplify all of these things. So then we're going to have this one over here. We got rid of all sine. Because we only have cosine here, so let's just have, instead of cosine, I'm going to, instead of cosine x, write it as t. And if we do so, let's see what we're going to have. We're going to have a, okay, this one expanded. I'm going to, instead of cosine x, I'm going to put it here. So we're going to have 4t squared minus 2at, okay, minus 1 plus a is 0. Okay, so now you would see that this is actually a quadratic equation. So let's just use the quadratic formula. So we're going to have, okay, so let's just use the quadratic formula. It's going to be t is equal to, okay, negative 2a is going to be positive 2a, plus minus, okay, a square root of, okay, we're going to continue it here. So for this one is squared will be 4a2 minus, okay, so because it's going to be minus, I'm going to write it all the way like this. So I'm going to go 16, 1 plus a, okay, divided by 8. Okay, so let's continue with our solution. We had this cosine x is equal to this because we solved the quadratic equation. We simplified, we get this, and it gives us two values. We know that the question is stated that x is between 0 and pi. So within this range, cosine x will be between -1 and 1. because cosine of 0 is 1, cosine of pi is -1. So what we're going to have is cosine x will be between 1 and -1. And here we have cosine x is equal to this value. So then we're going to have a plus 1 over 2 is between these two values. Okay. Now, because we need a range for a, let's multiply everything by 2. We're going to have -2, a plus 1, okay, is smaller than 2. Okay, let's subtract 1 from all parts. So it's going to be a will be between these values. Okay, so, but there's still a problem here. What is that problem? Here it said, the question is stated that we need two solutions. What if this value gives -1 over 2? Then it would become the same as this one, or -1 over 2. And then we would have one solution, right? But we need two solutions. So that means for whatever value of a that we have, it must be different. So for example, here, if we take a is 2, no, it can't be 2. If a is 0, for example, here, then cosine x will be +1 over 2, which is a good thing. We just don't want this cosine x to be -1 over 2 again. So that means we don't want the value of a to be -1 over 2 again. So we're going to have a plus 1 is equal to -1. Okay, so a -2. We just don't want a to be -2 because for this value, we're going to get one solution, not two. So we're going to have -3. A is supposed to be between these two. Okay, and -2 and 1. Okay, so let me clear this. So now the question is asking for the addition of these values. So it's asking for -3 plus -2 plus 1. So obviously, if we add all of this, we're going to get -4, which is going to be the answer to this question. So personally, if it was the test, I would skip this question or I would keep it as the last question if I had the time. Okay, let's do problem 18. Let Tk to be the transformation of the coordinate plane that first rotates the plane k degrees counterclockwise around the origin and then reflects the plane across the y-axis. What is the least positive integer n such that performing the sequence of transformations t1 to tn returns the point 1 and 0 back to itself? Okay, so the key to this question is understanding it. I'm pretty sure if you understand it, then you can do it, okay? And unlike the previous question, it doesn't take that much time either. So the point here is 1 and 0. So on y-axis, this is the y-axis, let me just show it. Here it would be the point, okay, right over here. Okay, and it says, okay, T1, the plane, let me just make it purple, is going to go counterclockwise. So do we have to regularly rotate the plane every time? No. If this one goes 1 degree, okay, this is the same as this one going counterclockwise by 1 degree. Actually clockwise, sorry. So the point will go 1 degree this way. Okay, but wait, does it really matter how the point moves? Well, after all, it's going to go like all these degrees, okay, and then come back to the origin, right? If you go clockwise or if you go counterclockwise with your point, it doesn't matter. Everything is symmetrical, right? So don't worry about it. So all you have to do is just keep rotating this point. Okay, maybe clockwise, maybe counterclockwise. So whatever you like better. So first, For t1, instead of moving this plane, I'm going to move the point for 1 degree. It's going to be the same. So first, we are here. We are at 0 degrees. Okay? So, and then we're going to go 1 degree here. We're going to move for 1 degree. So we were 0. Okay? Then our 0 going to be at 1 degree. Once the point is here, we're going to reflect it around y-axis. So it would be, the point will be right over here. Okay? So how many degrees is that going to be? This one was 1 degree, all of it. If that's the case, okay, going from here to here will be 180 minus this 1 degree over here. This is 1 degree. So then it would be 179. Okay, and the point we are at is right over here. So 179. Okay, so this is going to be T1. Okay, and then what happens? Again, we go T2. For T2, I'm going to change the color. So we're going to go 2 degrees clockwise because we started clockwise. We just have to go with whatever we started. If we go clockwise, okay, it's going to be 180 degrees here and 1 more. It will be 181 degrees. Okay, and then we are here. We reflect it against the y-axis. So we will be here. So you could write it here. It's going to be 1 full circle, but minus 1 degree. You could write it as 359. Or because it's simpler, I'm going to write it as -1. Okay, this will be T2. Okay, so now I'll change the color again. This time we are here. And this is only 1 degree. So for T3, we're going to go 3 degrees here. Again, clockwise. 1 degree here, 2 more. Okay, in my drawing, this is almost like 45 degrees. But here, this is only 2. I'm just drawing it larger so that we can see it better. So now we will be at 2 degrees. Okay, we reflect it again here. So from here to here, will be 178 degrees. Okay, that was T3. Okay, now again, clockwise, we are going to go this time 4 degrees. Okay, this is 2. We're going to go 2 more. So it will be 182. Okay, we reflect it again. This would be 2 less. So it would be like -2. And that would be the end of T4. So now we no longer need this. So I'm going to clean it. Because we have our pattern, we just have to, let me make this black. Okay. So just let's go and care about all these numbers that we have. Okay. So later, okay, let me go back to yellow. So later, this is look this one. Look at this one. This one is going like -1, -2, and then for T6 it will be -3. Eventually, this one. When does this one reaches -360? This one. It would be at T 2 times. See, T2, how -2 is 4? 2 times more. So 360 will be 720. Okay, so for 720, we definitely go back to the beginning. But we have to check smaller numbers too. Maybe it's also possible for those. So let's try for something smaller. Let's just try this one. What happens at T 360? Okay, so when we have T 360, This one would be half of this. This will be negative 180 degrees. Okay, so what would be the value of this number? Now, I want you to pay attention to these numbers that we have. For the even numbers T2 and T4, when we add these numbers, 181 plus negative 1 is 180, the sum of these. So the sum of these is always 180. This one is always 180. Isn't that right? Okay. So that means here I should write a number here that makes this 180 degree when we add them. Okay. So this will be 360 degrees. And this is going back to the beginning. 360 degrees is a full circle. So this one could be right. This one was also right, but these are larger. So we just have to look at the previous number, okay? Because we want the first time that it goes back to the beginning. Okay, so now let's see how this happens here. When we want to go from T2, or let's see here. I want to pay attention. Let me just change the color. Now, if we want to go from this number, or T2, like this one, when we are going here, we're adding 180 degrees to this number. The same thing is happening here. If we add 180 degrees, it's going back here. So let's just do that. Okay, for T, 359. Okay, we just have to add 180 degrees. So negative 180 plus 180 degrees, this is actually a 0. So for T, 359 is the first time that we go back, okay, to the beginning position. We'll go back again for 360. And obviously for 720, all of these are correct numbers, okay? But because we want the first one, so we'll choose A, okay? So I explained it a lot with details, but somebody who can process all that information quickly can answer this one very fast, okay? Okay, problem 19. Suppose that 13 cars numbered 1 through 13 are arranged in a row. The task is to pick them up in a numerically increasing order, working repeatedly from left to right. In the example below, cards 1, 2, 3 are first picked up. Okay, let's just see why. Because we have to go this one, this one, this one. Because 4 is not here on the right, we'll have to go back to here. So this is the second time we pick cards, 4, 5. Is there 6? No, we have to go back here. Third time, and here we just have to go fourth time, 8, 9, 10, and then we have to go back 11, 12, 13. I think it was like fifth time, fifth pass. So this is like fifth path, right? This is what it looks like. So for how many of these 13 factorial possible ordering of cards, not important, will the 13 cards be picked in exactly 2 passes? Okay, so now understanding the question is really important. Now, if I put here 1 here, 2 here, and then I'll go, for example, 3, 4, 5, blah, 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 all the way to 13. How many picks will that be? I'll have like 1, I'll pick 1 and 2, and then go back here to 3, and then I pick all of them, right? So now let me just put 1 and 2 here, for example, randomly. If 1 is here, 2 is here, see, now I have to go if I want to. See, I could put, if I go put 3 here, 5, 6, all the way to 13, it will exactly be like this. We pick 1, we pick 2, and then we go to the beginning. Okay. But we need to decide from where we need to go back to the beginning, okay? So we choose that. See, now I want to go back. If I put here 1, for example, here, 2 here, 3 here, okay? If I place 4 and 5 here, it still will pick them. But if I go to the beginning, okay, then I have to go by order. 4, 5, 6, 7. If I don't do this, for example, I put 7 here. If I go put 8 here, and I go back 9, well, that will be 3 passes already. So after you do the first pass, from here, everything will be forced from the smallest to the biggest, okay? Now, how many possibilities do we have? Okay, I want to say I place the first card and all of them will be forced. So from these spots, 13 spots, I pick one of them. I pick this. Because I want to force all other cards, okay? And I want to pass after this. I can't put 2, 3 here, okay? And I'll go and put 2 here, 3, 4, 5, all the way to 13, okay? I could do this with any spots. If I choose this one, for example, 1, then 2, 3, 4, 5, 6, 7. So that means from these 13 positions, I'll choose just 1, okay? So it will be 13. But if I put here 1, and then force the rest, like 2, 3, 4, 5, 6, 7, in order, this one will be 1 pass. So I'm going to write 13 minus 1 for the first one, okay? And I will go and write it this way. I'm going to choose 1 spot from the 13 spots. And the first one here, if 1 goes here, unacceptable. And I'm going to continue. Now, this time I want to just pick two spots from here. So I'm going to just choose this spot and this spot. Okay. I'll just put 1 here, 2 here, and then everything else from left to right will be forced. 3, 4, 5, 6, 7. Okay. So this way, okay, after 2, I count all the passes. So I'm going to go like this. This time, I'll write it here like this. I'll have to choose 2 spots from the 13 spots. Okay. So, but there is again the same problem. What if I choose from this 2 spots? This is one of the ways, right? So here, if this one is 1 and this one becomes 2, and I force all the 3 to 13, that will be again 1 pass, not 2 passes. Okay, so it would be minus 1. Okay, so you get the idea. So what if, okay, in my first pass, I pick 1, 2, and 3. To do that, I'll just have to randomly choose 3 from this 13 spots. 1 goes here, 2 goes here, 3 goes here. So from the left, each number will be forced from the smallest to the biggest. Again, it will be, okay, combinations of 13 and 3 minus 1. What is this one? What if 1 and 2 and 3 goes here? So this will continue. All we have to do is add all of these. So 13 and 4 minus 1. And what would be the last one? Okay, the last one will be 13, 12, and then minus 1. If I choose all the 13, the last one, okay, will be 1 pass again. So this would be the last one, which I have to choose 12 of these. So I'm going to just, for example, choose all these things. 9, 10, 11, and 12. So what's that going to be? 1 goes here, 2 goes here, 3 goes here. For the last one, 12. This one goes 13. This is an example of the last one. So we just have to find the sum of all these numbers. So how can we find the sum very quickly? I'll show you. Okay, to find the value of this expression very quickly, we're going to use Pascal's triangle. Okay, so to understand it better, what if you want to find what is the value of this combination of 0 and 3 and 0 plus 3 and 1 plus 3 and 2 plus 3 and 3. Okay, so look at it. It would be exactly this row over here. This would be 1 plus 3 plus 3, and the last one is 1. So to do that, all you have to do, go to power of this number here, 3. Okay, so you could go this for any number. But now, okay, let's see, for example, if you want for 8, okay, the 8th row will be right over here. So now what we are interested in is in this one. But remember, the first number that we have here is 13. And the last number we have here is also 13. Okay, so that means we want the value of this part in the question. So we have to throw away that extra 2 here. So all of this will be 2 to power of 13. But we don't want this, we don't want this. So it will be 2 to power of 13, okay? But we don't need these two, minus 2. Okay, so which is going to be 8,192 minus 2 will be 8,192. But we also had this minus 1 all here. So we'll have one of them here, one here, one here, one here. How many of this do we have? The first number here was 1. The last number here is 12. So we have 12 of these negative ones. I didn't write this one correctly. This one is 1890. Okay, because we removed 2 from it. Now here, minus these 12. So the answer here will be 8, 1, okay, 7, 8. This would be the answer. Okay, problem 20. Isosceles trapezoid ABCD has parallel sides, with AD being parallel to BC, and BC is also smaller than AD, and AB is equal to CD. So it's going to be something like this. These two will be equal sides. And there is a point P in the plane, maybe somewhere around here, maybe a little closer. So somewhere maybe like this. This would be our P because here would be 1, this one 2, this one 3, and this one 4. Okay. So what is BC, the smaller, the red one, over AD, the blue one? Okay, I'm going to clean everything because let's just think about this. If I pick this up, right, it still will have our trapezoid, isosceles trapezoid, right? If I put it down, again, we have it, right? So which one do you think is smaller, right? To make the question easier, I'm going to assume that the h is actually 0, okay? A trapezoid with the height of 0. So this will go all the way here, and this will be our B, and this one here will be C. And let me clean all this, okay? So this makes the question so much easier. And we do this because it's a test after all. We just want to find the right answer as quickly as possible. And now, where should P be? Okay, so PA is 1, PB is 2. Okay, so how is that even possible, right? Maybe the first thing we could think of is it's going to be here. This one, for example, will be 1. This one will be 2. Okay, this way it works. But if we do that, PC is supposed to be like 3. So this has to be 1. Okay, everything works now. So then PD will be 4. So if this one is also 1, well, if we draw it like this, is it possible? Now the distance is PA is 1, PB is 2. Okay, but the answer is no, because here the question says AB is equal to CD. So this section should be equal to this section, but here we have 3, here we have 1. So where is P? Okay, so P cannot be on the line actually. P should be outside the line. So if I go put P here, and this is A, if this one is 1, it works. If this one is 1, now PB is 2. This one is 1, PC is 3. And this one is 1. Okay, so CD is also 1. And the distance between P and D is 4. Everything makes sense. So that is a trapezoid. It looks weird, but it's just, I guess, the job done. So now we want BC, 1, over AD. So from AD would be from here to here, which would be 3. And this is our right answer. Problem 21, which of the following polynomials is a factor of px? Well, for this type of questions, if you know what to do, the question is actually very easy. Okay, so, and all you need to know about this question is this, really. What is x to power of m minus 1 divided by x to power of n minus 1, given that m is larger than n? If you're familiar with this is a doable question, right? Even in a test condition, problem 21, you can do it. Okay, so to understand this better, we have to start by an example. So for example, let's see, we want to divide x to power of 15 minus 1. Let's divide this by x to power of 3 minus 1. Okay, so please pay attention that 15 is divisible by 3. So what are we going to do? I'm going to write here x to power of 12. Okay, so I'll multiply it here, x to power of 15 minus x to power of 12. So because I'm going to subtract, I apply the negative just like this. These two will cancel. So what are we going to have? X to power of 12 minus 1. So what is the next one? We're going to need x to power of 9. So, and then the same thing will happen here. Minus x to power of 9. Okay, so once we cancel this, we're going to get x to power of 9 minus 1. And this will continue. So what we're going to do is going to be like this. So if we divide x to power of 15 minus 1 by x to power of 5 minus 1, okay, so we're going to get, see, x to power of 12, okay, sorry guys, this is 3, why did I write 5? X to power of 3 minus 1, okay, so we're going to get x to power of 12, and what is 12 minus 3? Plus x to power of 9, okay, again, plus x to power of 6, okay, plus x to power of 3, and plus 1, okay, so that's the idea. Let's just make another example so that I become really clear. So instead of 3, now I'm going to go with 5. So you tell me, right, what this is going to be. Now we're going to have x to power of 10 here, and then we're going to have x to power of 5, and then we're going to have plus 1. Okay, so now pay attention that, let's compare these two, this orange one here and this orange one. Do they look similar? But instead of 5, we're going to have 1001, right? And here we have 2002. So basically, this one will be how to create this one. If I go and write x to power of 3033 minus 1, and we divide it by x to power of 1011, okay, minus 1. We're going to get exactly this one over here. We're going to get x to power of 2022 plus x to power of 1011 plus 1. Okay, so let's go and use this. Okay, now let's check something together. So we want to find a factor of px, and this is our px written this way. Okay, now let's just try something. We know that x minus 1 is a factor of this because 1 divides 3033. Also, x minus 1 is a factor of this. Okay, right. So let me write it here so that it will be clear. So this one will be x minus 1. So the rest will be x to power of 3032 and blah, 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 right? So they will continue like this. And this one will be x minus 1. You get the idea, right? So it will be x 10 to power 10, 10, and again, it will continue. So do you think x minus 1 is a factor of this? Okay, because this one and this one will cancel. X minus 1 is not a factor of this, right? If you put here 1, it will be 1 to power of 2022 plus 1 plus 1 will be 3. Okay, definitely not a factor of this. Okay, so I could just make another example, right? Even if we write, for example, the largest one, x to the power of 337, okay, minus 1. We're going to get 9 terms here, right? It will continue, and this one continue. So again, this will cancel, right? So this one will not be a factor of that. But what do we need to find? Let's focus on that instead, okay? We need something that, okay, is a factor of this, but not a factor of this, so that they won't cancel, right? So to do that, we need to do some prime factorization. This one is 3 to the power of 2 multiplied by 337. This one is 3 times 337. Okay, right? So that means, let's just write it this way. The only number that wouldn't be canceled is this 9 over here. So this one, let's write it like this. X to the power of 9 minus 1. Okay, so the first term of this will be x to the power of 3024, for example. And then it will continue like this. This one, okay, so, but this one will not be able to cancel this. The only thing that is a multiple of 3 that could cancel it is this one. Okay, why did I write it like this? And then this one will also be something else. Okay, so what we're going to have, okay, these two will definitely form one of the factors here. All we have to do is divide these two together. It will be a factor of this px. Let's see what it becomes. We already know this. So x to the power of 9 minus 1. When this one will cancel, so let's just see, it will be equal to x to the power of 3 minus 1. Okay, so the first term will be x to the power of 9 minus 3, 6. And again, minus 3x to the power of 3. And then plus 1. Okay, so this one is definitely a factor of px. So we'll choose E. Problem 22. Let C be a real number and Z1 and Z2 be the two complex numbers satisfying the equation. Point Z1, Z2 and their reciprocals are the vertices of a quadrilateral Q in complex plane. When the area of Q obtains the maximum possible value, C is closest to which of the following? So when you see this question, you're probably not sure if you can do it. It's going to turn out to be easy or not easy. But it's problem 22. Nobody expected it to be easy. But I think it's manageable, right? It's not really that difficult. And I think it's also not difficult to understand. So here we have Z1 and Z2, okay, are two solutions to this equation. So what it means here, Z squared minus CZ plus 10, which is equal to 0, is also equal to Z minus Z1 multiplied by Z minus Z2. So if Z sounds unfamiliar to you, maybe you could swap them with X. Write the equation with X. I think it will be easier to understand it. So now let's compare these two, right? So because these two are equal, so we know that Z1 multiplied by Z2 will be this one. Okay, you could expand it and see it for yourself. Well, I could do it. Let me just expand this part, right? The right-hand side. It will be Z squared, okay? It's going to be minus Z, and then Z1 plus Z2. And lastly, plus Z1 times Z2, okay? So let's compare now. We know that this 10, let me change color. We know that this 10 is equal to product of the two. So product of the two is equal to 10, okay? And now comparing these two with this one, so we know that C is equal to this. So Z1 plus Z2 is supposed to be C. Okay, so well, this one, you don't have to write it, right? So most students, right, they already know that they are equal, so they could skip this part, okay? But if it's not obvious to you, that's why I wrote it. Let's go now. So we know that Z1 and Z2 are actually, let's just write it here. They are complex numbers. So Z1, let's assume this is A plus BI. Okay. Z2, I have to give different variables. I can't do C because it's already been used. So I write D plus EI. Okay, so they are different. Okay. Now let's compare. When we add Z1 plus Z2, it's going to be a real number. So what does that mean? That means there should be no I, no imaginary part in them. So if I just write it here, Z1 plus Z2, I'm going to add them like this. So Z1 plus Z2 will be A plus D plus BI plus EI, right? But here we also says that this is C, which is a real number. That means these two should cancel, right? How is that possible? If this is B, so E should be negative B. This is the only way that these two will cancel. So here, instead of E, I'm just gonna go and write minus B. This way, when we add Z1 and Z2, there will be no imaginary parts in them. Okay, good. So now we know that the product of them will also be 10. Again, 10 is a real number. So that means when we multiply them again, the I part, the imaginary parts, has to go away. So let's just multiply them. So Z1 is going to be like this, A plus BI multiplied by D minus BI is supposed to be 10. Good. Let's see how. So let's just multiply them. We're going to have AD, obviously. So plus this one will be negative ABI. And then this one will be DBI, positive. And lastly, it's going to be B squared. No, it's going to be minus. It's going to be minus B squared I squared. Okay. So now let's have this part over here. So this part, I squared, is equal to negative 1, which multiplies by this, and both of them will cancel. So we're going to have positive BI. Okay, great. So, but we know that this is supposed to be equal to 10. So look what happens here. This is BI. Let me change color again. So BI and BI are the same. So the only way that these two will cancel is, again, if A is equal to D, this will happen, right? And then they will happen. So here, D is equal to A. So let's just not use D anymore. And this one will be A. So that means Z1 and Z2 are in this format. Okay. So we know this. Okay. So now we just want to find these other two. So let's go and use that. But by the way, I think we should have continued this. So now instead of A, instead of D, let's write A. So this one will be A. Okay, these two will cancel. So what we're gonna have is going to be this. Instead of AD becomes A squared plus B squared is equal to 10. We also have this now. So let's write it here. A squared plus B squared is equal to 10. Okay, very good. Now we have these points. Let's also go and create 1 over Z1, which is going to be 1 over A plus BI. Okay, so now to simplify this, I'm going to multiply this by I minus BI. Okay, and also A minus BI. Okay, so the numerator, this one will be this. Okay, and let's just go what happens to here. This one will be equal to A squared minus B squared I squared, and this will be a negative 1. So here the denominator will be A squared plus B squared. Let me write it here. Denominator will be A squared plus B squared, which, guess what, is equal to 10, right? So 1 over Z1 will be this. That would be, by the way, let's just make this one A. Okay, so 1 over Z1 will be a minus bi divided by 10. Okay, let's go. So how about the other one? We just have to repeat the same process. And if you paid attention, it will be this one instead. So it will be a plus bi over 10. Okay. So we have for these 4 points, and this will create a shape like a quadrilateral. Let's draw it, and we want to maximize its volume. Let's see how. Okay, now let's just show our 4 points and see what they look like. Let's just start by Z1. So the real portion is going to be A. This is A. And the imaginary part will go B up. So it's going to be, this is B. It will be this point. Now the Z2 is going to be A, and this will be negative B. So it will be this point. Okay, we have 2 other points. The other ones, okay, will be A plus B, but divided by 10. So the same thing, it would be this point over here. And the other one will be right over here. So I'm going to clean this. So this one, if somebody asks us, what is the this axis? It will be B over 10. Right? I'm going to clean it. So let's connect these points and see what the shape actually is. So when we create it, it's a trapezoid, equilateral trapezoid. So but let's just write the formula for it. So, but before we do it, here it was from here to here is actually 2b, right? This one over here, the small part, is going to be 2b over 10, right? Which is going to be b over 5. So I'm going to write it here. And how about the height from here to here? This one was a, but this little part is a over 10. So it's going to be 9a over 10. So 1a minus 1/10 of a. Okay, so I have to clean these. I hope I'm not going to need them. Okay, so we have these points. Okay, by the way, before I clean these things, I need to write something here because I'm going to need them. So we had here Z1 plus Z2 is 10. So when we added them, right, it's going to be, I wish I did it at the beginning. So here, if I add Z1 and Z2, you would see that this will cancel with this, okay? So Z1 plus Z2 will be A plus positive BI minus BI, which will cancel. So we're going to have A plus A is equal to C, right? So we're going to have this equation here, and then I'm going to clean everything. So let's go back to our business, finding this area. Well, the area will be, okay, 2b plus b over 5. Okay, so half of this value, okay, multiplied by 9a over 10. Okay, so if you multiply all of them, so for example here, what's that going to be? I'm not going to simplify it, but this will be 11b, okay, over 10, okay, multiplied by 1 over 2, and multiplied by 9 over 10. See, this, I'm not going to simplify it. So you see now, it's going to be, when we simplify it, it's going to be blah, 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 okay, multiplied by AB. Okay, this is a number, a constant, right? So in order for the area of this to be maximum, AB should be maximum. Okay, so we're gonna have all this question will turn into all of this picture, blah, 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 is we have this one. A squared plus A squared is equal to 10. And we want AB to be max, right? We want to max it. This is not a great way of, but we need AB to be max, not equal. And so let's just go and do that. How do you think you can solve this? You could use differentiation, which will take a lot of time, or we could use this. We have a minus b squared, right? Everybody knows it. So a squared plus b squared minus 2ab. The reason I write it like this is because we have this one and we have this one, and then we could compare the difference between a and b. So here we have this one will be equal to 10. Okay. So, and here we have 2ab. We want this to be max. Okay. Let's rearrange it so that everybody will understand it. So let me take 2ab to one side. So here, this will be 10 minus a minus b squared. So you would see that AB will be maximum when it's 2AB will be maximum when this is 10 minus a positive value. This could be even or 0 or something larger than 0, something greater than 0. If it's something greater than 0, then this will be smaller. So to maximize this value should be 0. Okay. So when that's 0, when a is equal to b. Okay. So now we say a is equal to b. So because I'm going to need the value of c, so I'm going to need the value of a. So here instead of b squared, I put a squared. So we're going to have 2a squared is equal to 10. So a squared will be 5. So a will be square root of 5. Come on, right pen. Okay, so I'm going to need c will be equal to 2 of this. So c will be 2 square root of 5. And this is almost like 2.2, a little more, like almost. So 2 times of this will be almost approximately equal to 4.5, which is going to be this one. A little long and hard, right? So by the way, so you see each question, each problem has the same score. And it would not make sense if you spent so much time doing a difficult question where you got some of the easiest question wrong. So I always advise double check, right? You don't want the first 10 questions. You don't want a mistake in there, right? Because these questions are really difficult to do. Okay, problem 23. I think just understanding this question is a great deal. If you really understand it, then I think it's manageable and doable. So let's try to first understand the question. Let Hn and Kn be the unique, relatively prime, positive integers. What does that mean? Okay, so for example, could H be 4 and K be 8? Is it possible? No, because you have to simplify it as much as possible. Now 1 and 2, are they unique, relatively prime, positive integers? Yes. Not 1 so much, but the idea is that you have to simplify the fraction as much as possible. Okay, so that's what it says. Now let Ln denote the least common multiple of the numbers 1, 2, 3 up to n. For how many of these integers n between 1 and 22, kn is smaller than ln, right? When you read it, it's just like, what the hell, right? So what do? When this happens, you have to do a few of them until you understand what the question is, and then try to solve it if possible. So let's understand it. Now, if n is 1, it's going to be 1 over 1. Okay. Now, if n is 2, it's going to be like this, isn't it? So what are we going to do then? Okay, this will be 1 times 2. Okay, so look, 1 times 2 will be the least common multiple. So 1 times 2. So in this case, ln will be 2. Okay. And now once we add this, it's going to be 3. So this will be 3 over 2, right? So 3 and 2 are relatively prime positive integers, right? We can't simplify anymore 3 and 2. Okay, so in this case, hn will be 3 and kn will be 2. But the question says kn should be smaller than ln, but they are equal. So let's continue this a little more. Okay, so I'll add 1 plus 3 to it. So what is the least common multiple of these numbers? 6. Once we add them, it's going to be 11 over 6. Okay, so hn will be 11, kn will be 6. You see that? It's always like that. They're always equal. When are they going to be equal? When we could simplify them. So we have to continue to see like a fraction that they will be simplified. So this didn't happen with n3. So let's go and check n4. So what is the common multiple, the least common multiple of 1, 2, 3, 4? Okay, it's going to be just 12, right? So it will be 1 times, 2 times, 3 times. I don't write 4 over here, okay, because we already have a 2. So I write 2 here, right? It's going to be 12. And then once we add them, let's see what happens here. This was 12. This will be 12 plus, look, the second one is 12 over 2, right? It's going to be 6. But I'm going to write it this way. It helps. The next one is 12 over 3. And the next one is 12 over 4. Why do I write it this way? Because I hate you? No. Because I'm going to need this later. So let's go here. This will be 12 plus. This one 6, a 4, 10, 22, and I hope 25. I hope that I didn't make a mistake here. So let me do it again. So 3 and 4, 7, a 6, 13. Yes, it's going to be 25 over 12. Okay, so again, are they going to be canceled? No. So ln 12 again, kn equals 12. But look at these numbers, right? I'm going to prepare you for later now. See, the numerator. This one, the first number is an even number. 12 divided by 3, even number. But this one is all of a sudden odd. So this will be odd. So if you get odd number, never going to be simplified. Okay, so let's continue. Okay. If you do with 5, again, it's not going to happen. So I'm not going to waste any more time. So it's going to be 1 over 5 plus 1 over 6. Now let's go. What is the least common multiple of these? It's going to be 6, 12, 60. Okay. And these numbers is going to be 60 plus 60 divided by 2 plus 60 divided by 3 plus 60 divided by 4 plus 60 divided by 5 plus 60 divided by 6 is going to be 10. Okay, so now this number will be simplified. Let's take a look. So this would be 90, 110, 125, 135, okay, and 12, 147 over 60. Now, ln is 60. But look what happens here, okay? Both of these numbers could be simplified by 3, so they are not relatively prime positive integers. They're not. So both of them can be simplified. This will be 20. This would be 49. Now in this case, Kn is actually 20. So is Kn smaller than ln? Is 20 smaller than 60? Well, obviously. So n equals 6 is actually the first number. So this one is out. Okay. But how do we count all of them? Are we going to continue writing 22 like this? Definitely not. So I'm going to rewrite this part for you. See, now look, do you remember what I said? I said this one is 60 over 1. The second was 60 over 2. This one was 60 over 3, isn't it? So now let's turn this into something a little easier to deal with. So instead of 60, I'm going to write ln, and look what happens here. So the first one will be ln divided by 1 plus ln divided by 2 plus ln divided by 3, and we go all the way like this. Now it's so much easier to analyze things this way. Okay. So now let's see here. Why was this one divisible by? Why did they simplify? Okay. So remember, now we had ln was 60, right? Okay. So this one, 60, is already divisible by 3. Okay. This one divided by 2, divisible. But this one wasn't divisible by. So this one was 60 divided by 3. This one was 20. This one is already divisible by 3, 15. This one is already divisible by. So these are already divisible by 3. Now this one was not also divisible by 3. So, but the addition of these, ln over 3 and ln over 6, was actually divisible by 3. So let's write it here. So if I go ln over 3 plus ln over, okay, 6, what are we going to have here? It's going to be like 6, 3 ln. So now you would see here that what does this tree show? Okay. This ln over 3 was not divisible by 3. This one was not divisible by 3. But when we add them, this 3 appears in it. So now it's divisible by 3. That's why it was the answer over here. They got simplified. So now, okay. Now we know n equals to 6 is one of the answer. Okay, the next number that we need to check is n equal to 7, right? Then what would be the value of ln in this case? 1 times, 2 times, 3 times. I'm not going to write 4, I'm going to write 2 times 5 times. Am I going to write 6? No, we already have 2 times 3, 6 here. So I'm not going to do it. Multiply by 7. This is the value of ln, right? So let's check if this one is again divisible by 3. You see, ln is already, this number is divisible by 3. This one is divisible by 3. This one is not divisible by 3. Okay, so with the same case, ln over 7 is already divisible by 3. So all numbers are divisible by 3. Again, it's going to be ln over 3, ln over 6, right? So this one is just like the previous case. So n equals 7 is one of the answers, okay? So now let's check n equals 8. So if is n equal to 8, we already have 4 here, 2 times 2. I'm going to write 1, 2 to our value of ln. And then I'm going to add ln over 8. So with the same case, all of these will be divisible by 3, except these two. And we already checked that. ln plus 3 over 3 plus ln over 6, okay, will be divisible by 3. So ln equal 8 is already an answer. So B could be the right answer, but we have to continue still. Okay. But now let's see. N equal 9, things will make things different. See, why? Because now ln, we already have this. So our least common multiple of n equal 9, we have to check if this is the answer. Another 3 will be added. But now we have a 9 in ln, 3 and 3. When you divide 9 by 3, this will also be divisible by 3, divisible by 3. Even this one is divisible by 3. And then the last number will be ln over 9. Okay, the last number will not be divisible by 3. So we have all these numbers that are divisible, but the last number is not. So the whole thing is not. You have to assume like this. 3 plus 6 plus 3 plus 9. Like all the numbers are divisible, and all of a sudden we have 2. Is this number divisible by 3? No. So that's why at n equals 9, this would not be divisible by 3. Okay. So let me write it here. So n equal 9 is not. Okay, now let's continue. So is it possible for ln, okay, to be divisible by 2, right? We check these numbers. So is it possible? Now, this number, imagine this is ln, right? So this number is definitely divisible by 2. It's actually, there is like 8 in it. 2 times 2 times 2. This is even divisible by 8. But look, all these numbers will have 2 in them. So all of these numbers will be even, even, even. So all numbers even. Only ln divided by 8 will suddenly be odd. So we'll have a bunch of even numbers plus 1 odd. So you will see that the value of this, it doesn't matter which, is always going to be odd, but ln will always be even. So there will always be relatively prime positive integers. So you can't really simplify them. So that means you don't have to be worried about divisibility by 2. We check divisibility by 3. Okay, so now for ln, we have divisibility by 5. Okay, we have to check. See, now if it's ln, this is our value of ln. So if n is equal to 10, let's go and check that. So I just have to add a 5 to ln. Now this is the least common multiple for n equals 10. So again, all of these numbers are divisible by 5, except ln over 5 and ln over 10. These two numbers aren't. The rest of the numbers are divisible. So we have to check. ln over 5 plus ln over 10. Once we add them, see this one is not divisible by 10. This is not divisible by 5. This not is not divisible by 5. When we add them, we're going to get 3 ln over 10. So their sum will not be divisible by 5 again. So that means n equal 10 will not be the answer. So let's just check divisibility. Okay, now we have checked n6, n7, n8 was the answer. 9 not, n equal 10 not. We have to check n equals 11. So if we do that, our ln will be multiplied by 11. And this number, ln, is a multiple of 11. When divided by 2 again is. So the last number, ln over 11, this is not a multiple of 11. All of them are. This is. So you could think about it like this. You have 11 plus 22 plus 33. Of course, the sum of this is a multiple of 11. But if you just, the last one isn't, so the whole thing is not a multiple of 11. So that makes everything not divisible by 11. So n equal 11 for that reason is not. n12 will not be. You could just try. It's not divisible by 3. n13 is not. We have to check n equal 14 because ln over 7 plus ln over 14. What's that going to be? It's going to be again 3 ln over 14. Okay, now you'll see that the sum of these two numbers, okay, this ln, there is 7 in it, but it will be canceled by the 7 in this 14. So the sum of these two numbers here will be a number that is not divisible by 7. For that reason, n equals 14 is not the answer. So we have to check n equals 15. Okay, now let's check if n is equal to 15. There is a possibility we have to check. So we'll have 3 numbers that will not be divisible by 5. So ln over 5 would be here, plus ln over 10, plus ln over 15. These numbers will not be divisible by 5, but maybe their sum is divisible by 5. We have to check. So when we add all of these, it will be 30. This one will be 6 plus 3 plus 2 ln. So the sum will be 11 ln. So let me clear it here. So this one, you would see this 11 will not help to make it divisible by 5. Okay. So 16, 17, no, we don't have to check it, but 18 we have to check. Okay. So so this will continue until we'll have ln 18. Okay. So in our ln, okay, the least common multiple will be blah, 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 something, right? I'm going to write it the constant, multiplies by 9. There will be 9 in it, okay? So now when we have ln, this is divisible by 9, okay? This one is divisible by 9, okay? So this one, there is 9 in it, we're divided by 3. This one is still divisible by 3. So all these numbers are divisible by 3 except 2 things. ln over 9 plus ln over 18. We have to check. These two numbers are not divisible by 3. So let's add them together. So it will be 3 ln. So this 3, when you add these two, would make this number actually divisible. So by 3. So n equals 18. Okay, we'll just continue to do that. N equals 19 will be the same. N equals 20 will be the same. So n equals 21. Okay, you could check it. still would be divisible by 3. And the last one, n equals 22. So as you see, we'll have 8 values for which kn will be smaller than ln. So if you watch this, still you're not sure, it's unclear. So the reason is that you were just watching the video. I want you to just take a pen, try to write all the numbers, okay? And then watch the video. As you do it, then it will be clear, I promise you. Okay, let's do problem 24. How many strings of length 5 form from the digits 0, 1, 2, 3, 4? Just one thing. Why do we have the word string and not a number? Because, for example, 0, 0, 0, 0, 0 is not a number, but it's a string. So, for example, 0, 1, 2, 3, 4 is not a number because we're starting off with a 0, but it's a string. Okay? Such that for each j that belongs to this group, at least j of the digits are less than j. For example, 0, 2, 2, 1, 4 satisfies this condition because it contains at least one digit less than 1. So basically it says it's okay. 0 is okay anywhere. If you want to put 1 in the numbers, you have to have at least one 0. Okay? If you want to put a 2, you have to have maybe two zeros or a 0 and 1. Okay? So if you want to put 4, you have to have 4 digits that are smaller than that. Okay. And this one, for example, is not acceptable because suddenly we have 2. But to get 2, we need to have at least 1 0. We have to have 2 zeros or a 0 and 1. We don't have it, so it's not going to work. And now it says how many ways we can just make up that a string. So as you see, the numbers are not really that small. And if you do casework, you'll have a lot of possibilities. So what I think about instead is just instead of going with 5 strings, like 5-digit strings, let's go with 1-digit string first. So it would be 0, right? So only if we have only 0, how many ways can you place 0? Of course, 0, which is, you can put 0, which is going to be like 1 way. So if you have only 0, that means your n will be 1 digit only. And how many ways can you place 0? Obviously, just put it there, 1 way. Now, what if n is equal to 2? That means you're going to have a 0 and 1. How many strings can you make? 0 and 0 would be 1 way. 0 and 1 will be another. 1 and 0 will be another. Can I place 1 and 1, however? No, because to place a 1, you need to have a number that is smaller than 1, which we don't have. So in this case, it will be 3 ways. So if your n is 1, the answer is 1. If your n is 2, it's 3. Now let's go with n3. Okay. So if it's n3, we're going to have these digits. We're going to have 0, 1, and 2. So how many ways can we do this? Okay, let me write them all down. So obviously 0, 0, and 0. Okay. The next one is if we have 2 zeros and 1 other digits. So it could be 0, 0, 1, or 1 could be in the middle, 2 zeros here, or 1 here, 0, 0. The same thing could happen with 2, like 0, 0, 2, 0, 2, 0, and 2, 0, 0. Okay. So, but now you could see in this case, we have 3 zeros. In all these cases, we have 2 zeros. Now, what if we have 1 0? So it's going to be 1 0, 1 1 is possible. 1 0 1 is possible. And lastly, 1 and 1 0. Is there more? Yes, of course. So we're going to have 0, 1, and 2. Okay. So this way, we'll actually go like 6 more. Like 0, 2, 1. Okay, 2, 0, 1, 1, 0, 2, 1, 2, 0, 2, 1, 0. So how many ways is that? I wrote it to make it as clear as possible. So that's a 9. This is 615. It's going to make a total of 16 ways. Okay. So can you spot a pattern with this? Because if we can, then that's the answer here. 1, and 1, 1, and 2, 3, and 3, 4. So you could go on and do with n equals 4 as possible. You can do it like that. It would be much, much easier than this. Okay. So, but you would see here, because this increase was small and this increase is really high. So that means it's going to be exponential, right? So it's going to be whatever the formula is, it's going to be something like this. Okay, it's going to be exponential. So 16 could be 4 to the power of 2. 3 could be 3 to the power of 1. This could be 4 to the power of 2. And this could be like 1 to the power of 0. Okay, if we do it like this, so now n is 3, this is 4, so it's going to be n plus 1. And n is 4, this is 2, so it's going to be n minus 1. By the way, so you would guess this much faster if you know about parking functions or parking functions formula. Then it says, it's going to be a parking function. Or if you guess it's going to be a parking function question, you just have to go with the smaller cases. If it's following this formula over here, then it says, I'm smarter, right? I don't have to do it like the big one. I would just follow this formula. Okay, so in this case, the question becomes easy. So if you, however, go with n4, it's going to be 125. But we're going to go with n5, it's going to be 6 to the 4th power. Okay, it's going to be 36 squared, which is going to be E. Okay, finally, question 25. A circle with integer radius r is centered at RR. Distinct line segments of lengths CI connects these 2 points for i's between 1 and 14 and are tangent to the circle where A, B, C are all positive integers, and what is the ratio of that. Okay, so this one, understanding it is the key, right? Because when you read it, probably you don't know what it is. But once you understand it, it's so much easier. I wouldn't say it's easy, but it's a lot easier. And it wouldn't be so hard to understand either. Okay, so let's begin. But I need to just, because I'm gonna need more space, we just want C14, the last value of C over the first value of C. So I'm gonna clean this part. Okay. So let's see what it really means. So I have to draw the coordinate lines here. Let's do that. Okay, so let's see. Here it says a circle with integer radius r is centered at R and R. Okay, so this one, if we go lower like this, x-axis here, we're going to have value of R. Let's see if I can write it. This is going to be R. And if we go to the left intersecting y-axis, it's going to be R again. Okay. Now here, distinct line segments of length CI. Okay, let's see here. Or what's the difference between line and a line segment? Well, line will continue forever, but segments are going to be like a stop at 2 points. So a line segment will be like this, stopped and limited on both ends. So how can you go a segment that is tangent to the circle and it's going to like connect these 2 points? Okay, one of them is going to be fully on x-axis This is going to be on, so this is going to be like over here. This is going to be like on y-axis. The other one is going to be on x-axis. Okay. So let's see here what it looks like. How can you draw a line that is tangent to the circle? Like this would be, for example, one of them, right? It's tangent to the circle and it's just connecting all of this. Okay, so this will be A. Let me also change color. So this would be A and this would be B. So how many line segments like this can we draw? Well, can I draw it like this? Sure, I can. So it doesn't matter. With each slope, I can go like forever drawing infinite number of line segments like this. Okay. Now, is it all? Can I go some other way? The answer is yes. See, if I go like this is again tangent at this point, right? This is tangent at this point, and it will intersect at this place. It's going to be B. And here we'll continue it here. It will come to an end here at point A. Okay. So again, this is going to be another one. So, so as you see, there are limitless number of line segments that we could draw. So we need to narrow them down and limit them. How did the question did that? By saying that R is integer, A should be integer, B should be integer. Okay. And so with different values of R, so for example, imagine if R is only 1. Okay, a circle with like radius of 1, okay, which is going to be here and here. So not the perfect picture. So how many lines can you draw like this so that A and B, the intersection points, are also integer? So that's the question we need to work on. Okay, so let's do that. Okay, so let's continue. We know that R is supposed to be an integer, okay, and usually the larger the R is, most likely, the more values of A and B we're going to have, okay? Most likely, I said, this is like our prediction. And also, for example, if R is 4, imagine R is 4, then we're gonna have some more integer values for this one here, okay? So we're gonna do both of these individually, right? So for now, we're gonna have from here to here, this is A, so that means this line is also, how large is it? It's going to be A. And this one is going to be, all of it will be from 0 to B, so it's going to be B. Okay, now let's begin. And this line segments from here to here, the question is going to call all of this C. So from here to here is going to be C. Okay, because this is a right triangle over here, so obviously we could write A squared plus B squared is equal to C squared. But now there's a problem. This equation does not involve R, okay? So we need an equation that relates, like for example, the value of A and B and R together. So how do we do this? Okay, we have to think about it like this. Okay, this one, I'm gonna call this one. We know that this length is equal to this length, right? It's tangent to both of them, okay? So from this point to this point is equal, right? So let me change color. So from here to here, they're also equal. Let me go here. So from here to here, they're also equal. Okay, these 2 points. Okay, so how is that going to help us? Okay, so you would see that the value of C, okay, now let's focus on this part, the red one, like here. Okay, from here to here, if this is R, this is the radius. So that means from here to here is also R. Good. So all of this was A. From here to here, all of it was A. So that means this portion is going to be A minus R. Let me write it here. So this one is going to be A minus R. Okay. So here, over here, because I said they are the same, they're coming from outside the circle, both of them are tangent, so they're equal. This is going to be A minus R. And the orange one, again, all of this was B. So this little portion is equal to this portion, or R. So this portion will be B minus R. So is this. Now look. So instead of C, sorry, what can we write? So C, so I'm going to change color. So C is equal to A minus R, okay, plus B minus R, isn't it? So now, okay, the value of C is equal to A plus B minus 2R. And I'm going to take this C and put it here. Okay, replace that value. When I do so, we're going to include R into the main equation. So let's just do that. So we're going to have A squared plus B squared is equal to A plus B, okay, minus 2R squared. Okay, that's very good. Okay, now we have this equation. Okay, there are 3 variables, A, B, and R. But we know that A, B, and R are supposed to be integers. And we want the smallest value of R, for which there are 14 solutions for A and B. Okay, so probably if you go R1, you'll have the smallest number. And if you go more, they will increase. This is what we know. So let's just go and expand this one and simplify a little and see what it looks like. Okay, and let me clean this part. Okay, now let's go and expand the right hand side. So it's going to be A squared plus B squared and plus 4R squared. Okay, and we're going to have 2 ABs. Okay, and we're going to have negative 4R A plus B. This is what we're going to have. Okay. Okay. So we're going to just see that this A squared and A squared, B squared and B squared are going to cancel. Okay. And I'm going to divide each term by a 2. Since all of them are even numbers, I'm going to do that at once. So we're going to write it as 2R squared. Okay, plus 2AB, plus AB minus 2R A plus B is equal to 0. Okay, so, and then I'm going to add this. So I'm going to write this one as 4R squared minus 2R squared. Okay, plus AB minus 2R A plus B is equal to 0. Okay, so this one will go to the right hand side. So what we're going to have something like this. It's going to be A minus 2r times b minus 2r is going to be equal to 2r squared. So now why do we write it like this? Because we write it as the product of two things, like we factorize it. So it helps us narrow down all the options we have. We could count all the integers that could work for this, okay? So let me do some cleaning and then we'll be back. Okay, now we need to guess a value for r, okay, that will create a lot of factors, right? We want 4 different answers and solutions for this equation. So for example, if r is equal to 1, all of this will be 2. And then what is possible? Maybe one of them 1, the other one 2, maybe this one 2, this one 1. Maybe it's possible that -1 and -2, maybe that could also work. But you would see that's not enough. So because there's not enough factors in like r, this 2. So what is your guess? What number? 4 is going to be 2 times 2, not a lot of factors. Okay. So if r is 3, it's going to be 18. You could just go with r3 and see what happens. But I'm going to go with r equals 6. That will most likely be the case. But you could just go with r equals 3 and say what happens here. So if r is 6, okay, then the equation turns into a minus 12 times b minus 12 is equal to 72, right? Now, how many solutions does this one have? Okay, so 72 is equal to 2 to the third power multiplied by 3 to the second power. So how many factors does this have? It's going to be 3 plus 1 multiplied by 2 plus 1. Okay, so it's going to have 12 positive factors, right? Which one? So for example, once this is 72, then this is 1. Then this is 36, this is 2. Okay, then this is 18, this is 4. This is 9, this is 8. Okay, so, and then it gets smaller. For example, this is 8 now, this is 9. Okay, so we're going to have 12 different answers already. But is it possible for any negative values to do that? See, A and B are supposed to be positive, okay? So if this one is -8 and this one is -9, okay, we're going to have A will be +4, okay? And B will be +3. Okay, so A and B are positive, but these products are going to be like 2 negative numbers multiplied. So, but is there any more? So if it's not 9 and 8, 8 and 9, what is the next one? That is going to be, for example, 18 times 4. Okay, but they're supposed to be negative. So if this one is negative, then A has to be -6. So, okay, how many solutions did we find? Here, okay, we found 12. If this one is, once this is -8, this one is -9. Once this is -9, this is -8. Okay, which will produce A equals 3, B equals 4. Okay, so that's our 14 answer is the question wanted. So the value of R is equal to 6. You go try and R is equal to 3. And before I forget, do you remember at the beginning of a video I said there could be a tangent line like this? You go and repeat the same process and you will get exactly the same equation. I'm not going to do it here, okay? But you could definitely do it at home. So that's the answer. So R is supposed to be 6. With R equals 6, we're going to have 14 different solutions, okay? And now we want the biggest one divided by the smallest one. The smallest one happens at -9 times -8 because it will produce the smallest number. A will be 3. A3 and B4 will be the smallest. And the Pythagorean theorem will just say that, well, C is going to be 5. Okay, this is the smallest. And the biggest one happens at 72 times 1. Then A will be 13. Okay, and B will be 84. Okay, so again, we're going to have C squared will be 13 squared plus 84 squared. Okay, is going to be 85. So we're going to have two values. Okay, for C, the biggest one will be 85, the smallest one would be 5. So we just have to divide these two because the question asks us to do that. So we're going to go 85 divided by 5. So the ratio will be 17. Well, that was a difficult question, but it was, if we had a lot of time, it wouldn't be impossible. But during the test, it's really, really difficult. So by the way, this is the end of the video. So I hope you found it useful. If you did, contact me and let me know. And by the way, if you are preparing for this AMC Australian Mathematical Competition physics courses, you could contact me. We could have lessons together. I have my email, Instagram, WeChat, Telegram, all of this on the About page of my channel. Go check it out, contact me, and we can have classes and we see each other in class. So this is the end of this video. I hope you found it useful.